Cool. Welcome, Bernardo. This is fun. It's fun to have a colleague from Parity here on seminar. Welcome, everyone else. We are right on time today. I think we have some exciting things to cover. So I thought, yeah, well, let's just get right into it. How you doing, Bernardo?
I'm good. How about yourself?
Pretty good, pretty good. Last seminar was sort of very untraditional. We had panelists from Parachain Builders. This time we're back to kind of normal seminar, which is fun. Um, but yeah, I'm feeling really happy to jump back into seminar here after 2 weeks of being off, basically. So I do have like one super important announcement, and this is that the call for proposals for the new Polkadot Decoded is out. So I'm going to paste the link in the chat. Um, and you can check out this Medium article about it, learn how you can get involved, whether you're a developer, whether you want to like present some cool ideas for the Polkadot ecosystem. The event is being hosted in multiple cities. So Mexico, New York, Berlin, Bernardo, am I missing some? I think so. There's Mexico City, New York City, and
New
Berlin,
York?
and New York. Yes. Um, so check that out. Like it's just super exciting to have like different perspectives and different proposals and stuff that you're working on, either as a team or as an individual developer. So yeah, please submit your call for proposals. So without further ado, let's get right into it. So Bernardo, like, what do you do at Parity? Why don't you tell us a little bit about, yeah, what's your day to day like, and what are you passionate about working on in this space?
Uh, yeah. Well, I joined Parity in September last year. I'm on the ecosystem success team, so I've been working a lot with Benjamin Wise and Santiago Balaker. There's some other people too. There's the names maybe most people have already interacted with in the community. So we're basically always trying to make the ecosystem successful, right? We're trying to have initiatives that will really nourish and foment innovation in the ecosystem and make sure that the teams are building amazing projects on top of Polkadot as a protocol and Substrate as a framework. So we have the Substrate
So
builders. Sorry.
So when you say teams, like, do you mean, yeah, like full blown kind of developer teams building parachains, or can it also be like individual developers working on specific projects? So yeah, I'm just curious about that.
So we have the Substrate builders program. This is
Cool.
the main vehicle that guides most of our daily interactions. The Substrate Builders program has three main tracks. There's one that's called the Chains track, which is like most Substrate teams are building chains, right? So they're doing some development on top of Substrate and writing their ballots, and maybe they want to go for a parachain slot and things of that nature. Then there's the applications track, which is more on the DApp level, maybe teams that are writing some smart contract and the front end for that and all the interactions that are going to be happening uh, in that sense. And then finally, there's the infrastructure track, where maybe teams are doing some things in the nature of on finality, for example, like node infrastructure
Right.
or things that go in that direction.
Mhm.
So yeah, that's pretty much it.
Super cool. So yeah, your day to day is helping those teams build and at least find the solutions that they're looking for.
Yeah.
Super exciting. So today you've prepared something very interesting, kind of very sort of specific to when you're building your palettes. You need to be very conscientious about the way that you've kind of economically designed your dispatchable functions. Because as we know, like we as runtime engineers need to be they take into account sort of there's a finite amount of computation every block can hold. And so basically, if we exceed that amount, well, we're putting in danger sort of the block production of our blockchains, and sort of we are opening up a whole bunch of attack vectors. So I'm curious in just hearing like a little bit about the motivation behind doing this work, which is, you know, that I'm going to share some links right now for people watching and in the chat. But this you call it the chaos palette, which I think was pretty cool. But yeah, what's the motivation around it, and then maybe you can just jump right into whatever you have prepared for us today.
Yeah. Well, just going in some brief introduction. This is kind of just a crazy experiment that we were brainstorming how to raise awareness on first on benchmarking, around benchmarking. Then I kind of try to expand that a bit. Alex Popiak gave a similar presentation a while ago. He has a repo on his GitHub account with a similar idea on how not to build a palette, right? And the idea is just like to make Substrate work in a way that it's not supposed to, see what happens, see what breaks, and take the lessons, carry on the lessons from it. So maybe I have prepared some slides, and I guess when we're following them, we can dive a little bit deeper into that rationale. I'm going to share my screen so we can start.
So as per usual, guys, don't be shy. Ask your questions in the question box. That's what it's there for. I'm here to kind of moderate and also ask questions. So if you have cool questions, I'll be the first to kind of pick them out and interrupt Bernardo here in his presentation. Yeah, use the question box.
Can you see the slides?
Yep, crystal clear.
Cool. So yeah, Substrate Chaoscope, violating Substrate best practices to see what happens. So first, let's just dive into a kind of a discussion on what could be seen as economic attack vectors on Substrate. If you look at Substrate runtimes as with this umbrella abstraction framework of it is a distributed virtual machine, right? Even if you're not necessarily executing smart contracts, I know that the idea of a virtual machine is usually associated with smart contracts. Substrate smart contract free runtimes, they can still be seen as a distributed virtual machine. It's just about how the logic is programmed into it, right? This is done on the runtime itself. It's not dynamic in the way that smart contracts are, but still, let's look at it as a virtual machine. And so whenever a distributed virtual machine needs to execute state transition functions, there's a specific cost attributed to the virtual computation resources that are allocated for such transformation. This cost is usually covered in the form of fees that are charged to the user, so that the system can function in an economically sustainable way. And the relationship between these fees and the computational resources that are allocated from the virtual machine is very critical for the economical safety of the system. Poorly designed fees, they can leave room for denial of service attack surfaces, because basically an attacker can flood the system with resource expensive but economically cheap operations, and then they're slowing down block production, and they're effectively denying service from a significant number of users. And
so
they can
just if you don't mind me interrupting, so I'm curious in hearing maybe from your experience, like, have you seen some common like DDoS attacks specifically? Like, what kinds of extrinsics would an attacker kind of engineer? I understand that, like, generically, like, we're talking about, you know, cheap, sort of low economically extrinsics of low economic value, but doing a lot of them, right? So flooding the system with it. But what
Yes.
would an example of that be? Have we seen this at least in the Polkadot ecosystem?
I don't know. I don't think this has happened in any chain that's in production right now,
Mhm.
uh, which is a good thing. I hope I'm not encouraging people to do that. That's not that's not the goal here. Please don't do that to any chain that's live. The goal here is more to show people what could happen
Yep.
if things are not taken care of. So that's a really good question. I wish I had a concrete example. Maybe that's something that I should put more research to have some good practical example, and maybe something that has already happened in our community of a similar nature, so we can give a better picture here.
Right. Yeah. No, I think it's just interesting to sort of put more of a like a specific story or something that happened to like this general like everybody knows what DDoS attacks, but there's different ways of executing one. And to your point, I think that it's a great thing that people can try, right? Because that's why these systems are robust. At least this is what we're trying to build, right? We're trying to build
Hmm.
robust systems that can withstand any types of attacks. And I think that's basically what we're talking about with this slide, with economic vectors that we need to be conscious about. But I'll leave it at that, and I'll let you keep going. This is cool.
Cool. So coming back to Ethereum, right? To kind of make things a bit more familiar. Uh, with Ethereum, we have the concept of gas, and it works as a correlation between EVM resource consumption and economical fees. Uh, that's related to the halting problem in terms of how the virtual machine works. But basically, when we bring it to Substrate, we have the concept of weights, and runtime engineers, they can attribute appropriate fees for each extrinsic operation of the pallet so that their fees are properly designed, right? And then the pallet is, let's say, DOS attack resistant. So that was the original motivation. Like, let's write something that we really expose this sort of attack vector in the most obvious sense. So I started writing what I call pallet chaos, and the goal there is just to inject chaos into a runtime, just make it behave in ways it's not supposed to, and explore runtime edge cases, explore weights and their economic implications, and illustrate some possible attack vectors. So the first meaningful, first relevant extrinsic implementation we have on Pallet is it's called drag block unit weight. So basically, we're injecting a heavy computation payload into the runtime, and in practice, we're dragging down block production because we're calculating hashes in a loop n times, right? So n is an input parameter, but we're always using a unitary extrinsic weight. So the runtime understands that this is a super cheap, ridiculously cheap operation, while in fact, in practice, it's like we're calculating hashes in a loop. We're kind of, well, you could draw a parallel with mining here, right? We don't really have any logic related to nonce or anything of that nature, but we're just wasting CPU cycles. And while properly designed weight of this nature would the weight would increase linearly in proportion to n, to the how many times we're looping. Instead, we're just keeping it locked into a unit weight, and then we can see what happens in practice. But I started expanding a bit, adding some other extrinsics just to illustrate some other points as well. So we have also, for example, overflow adder. We start an adder storage object, and it is encoded as an unsigned 32-bit integer. And then whenever, and we're not adding it safely, right? So whenever the result goes above its limits, the adder overflows. So we just, with this extrinsic, we're just illustrating the importance of using safe operations such as a checked add or checked sub and their variants from the substrate primitives.
So the adders though they're very different from the other function that you showed, because if I understand correctly, the first function basically is overloading the block size. Like there's only finite amount of computation available in a block, and it's going to create hashes. The drag block weight unit, the drag block unit weight, sorry, that this extrinsic here, if I understand correctly, is basically filling up the block with like excess computation.
Yes.
Correct? But the other one is just doing like unsafe math. So how does the runtime like kind of understand these like violations differently?
Yeah. Well, the overflow adder is kind of a more silly example, if you will. Like we're not, like you got it right. We're not really exploring the same design principle that in the drag block unit weight extrinsic. This, I just wanted to kind of keep to this original goal of the chaos module in just making substrate runtimes behave in ways they're not supposed to. So I'm kind of going in different directions here.
Cool.
And when we get it running, we just see how they behave. But right now, these two extrinsic implementations, they don't have much of a correlation between them yet.
Right. And I guess like going back to sort of, this was all inspired also by like sort of bad, like things not to do when you're runtime engineering, and basically the unsafe math is a huge sort of no, right? We want to be using checked add and checked sub. We can't just do arithmetic operations that would lead to overflow.
Exactly. Yeah.
Cool.
So going forward, then we have Chaoscope, which provides a binary executable that just makes RPC calls to these two extrinsics exposed as command line arguments. So it just makes it, we can kind of automate over these calls instead of just manually interacting with them over Poco.js or something of that nature. So here's an example on how to call this binary and just get it to drag block production with a unit weight extrinsic and to use this number as the input parameter. We also have a shell script that automates some activities there. So we're just applying pallet chaos on top of substrate node template. And then it starts this node, it collects the metadata so that we can build our binary with subxt. And then it just shoots some calls to the RPCs and collects data so we can understand what's going on. So yeah, I have some observations here, but I think now it's probably a good time to just put this to action. So I have Chaoscope on my machine, and we have the shell script here. So we just call it. It builds the node template.
So to be clear, this is just the palette chaos in a node template. You're running it, and then you've got a script that's basically running some separate program that is making RPC calls to the node.
Yeah, maybe we can just take a quick look at the script itself, right?
Yeah, I posted this in the chat. I'll post it again, sort of more specifically, because we are looking at a specific file in this chaos scope.
Yeah, so we have a few functions on this shell script. It clones node template. It adds palette chaos. It builds node template. It starts node template. We have this function to get the metadata from it, just so that we know that maybe we had added some new calls to the runtime. This would automate the metadata updates in a way. And finally, we have some calls here for overflow adder and to drag block unit weight. So for overflow adder, first we add 1, then 10, then 100, just to see what happens. And then we intentionally overflow it and see what kind of value do we have in storage. And for drag block unit weight, we call the extrinsic. This is extrinsic with n. We vary n with a few numbers, and then we see what happens. So it's getting executed here while we talk. So the first part has already happened. So this is the overflow part. So first, remember, we just have, let me go into palette chaos implementation. We have another.
So that's just
storage.
a U32, an item in storage that holds a U32 value. Yeah.
Yeah. And then we just keep adding to it. So first we add 1, then we add 11. Sorry, we add 1, then we add 10, then we get 11, then we add 100, then we get 111. And then we just, let's overflow it. And we add this huge number.
That's the next. Yeah.
But then the storage value, it just flips to 110.
Yeah.
So it's kind of like, see, we should have used checked add here instead of
right.
Instead of just doing this. We're not checking for an overflow here. We're just doing a raw addition. We should have done this instead. And because we didn't do it, we just got something. We should have got an overflow error here. The runtime should
can we be very explicit and state why this is bad? Like, how does this sort of affect applications that we might be building?
Yeah.
Using these
let's say this adder here represented something meaningful in your chain, right? Let's say this is a counter of users, or I don't know, whatever meaningful number this is representing. And then
perhaps you're keeping track. Like a typical example, I guess, would be you're keeping track of the total amount of existence of some NFT in your system, right? So you need this value to sort of correctly add up as time goes by. What if after it reaches basically what the value is equivalent to max U32, which is that large number, or at least that one. Well, then it flips back to it overflows. So all of a sudden you go from having, this huge number of NFTs in your system, but then suddenly it goes back to like 100. That's not a good thing, right?
Yeah, and if you didn't use check that, and you're just counting that your runtime behaves in the way that it's supposed to, then you're not gonna, whenever this overflow happens, life is gonna go on as usual, and you'll have this weird number that represents something that is completely meaningless, and you think your runtime is fine when it's not.
Mm-hmm. Right. Yeah. So there is a question here. Actually, there's two questions. We'll go with the first one. So how to design fees for extrinsics that have variable computational demands depending on input? right?
Yeah. Well, in the Substrate documentation portal, we have some instructions there, right? Maybe I could. We have some steps that kind of guide your hand on how to. Well, first you gotta use the benchmarking tool, and there's a bunch of steps here. And basically, you create this benchmarking tool will create a weight.rs file that is going to take care of that. And then you just got to bring these weights into your runtime implementation.
Yeah. And so, and to add to that, so basically the way that you can calculate weights dynamically, and I think there's a guide about how to do that. I'll put it in the chat. And essentially, like, sure, that's a really good question actually, because like, what if you had a function where, given certain conditionals, like it goes through a bunch of if statements, the computational expense is going to be different, right? Logically. So if you have like a very simple sort of order one like computational complexity, and then you have suddenly it goes log n. So how do you kind of account for that? Well, you can sort of create custom weighting functions essentially that take into account these positions. And benchmarking is getting better and better with Substrate. So ultimately, the goal of benchmarking is to say, okay, I know that these functions have a worst case scenario. I need to be as precise as possible at calculating that worst case scenario, so that I can safely, allow users of this palette, or right, sort of external users using this blockchain, to make to use these dispatchables without breaking the underlying block production. So it's a great question, and the answer is that there's a lot of things that you can do with like customizing your weighting functions, and it all kind of comes down to benchmarking your dispatchables. I hope that answers your question. So the other Bernardo, did you have anything to add to that?
No, I'm just kind of going over the. I hope showing on my screen. I guess this one is kind of related, also to the answer.
Exactly. That's a good example. So yeah, it's funny because we haven't really like explicitly talked about benchmarking, because I think that benchmarking is one of the things we're looking at right now, where the whole idea of the chaos scope, what we're talking about today, this palette chaos and submitting extrinsics to a node that has a palette that essentially is showcasing bad practices, right? Well, one of the things is weighting your functions correctly and benchmarking, and the other one is make sure that you're using checked out and checked sub, because you need to be doing safe math. But the first part really is important, because I like, we're talking about how important it is to benchmark your functions, and how important it is to assign correct weight values, because that is essentially a fundamental part of having an economically safe blockchain.
Yep. So coming back to the script, after it does the overflow example, the script goes into the block production example. So
cool.
We vary n, right? We vary the loop size on some orders of magnitude. So whatever number this is, 10,000, then 50,000, then 100,000, then 500,000. And the fees, it always shows the fees paid. So here we see that this number is kind of subjective, whether it's a lot of money or not enough money. This is related to the tokenomics design of the chain. But the important thing is it's constant, right? We're greatly varying the magnitude of this input parameter. We're greatly varying the size of the while loop that's running inside the extrinsic call, the for loop. and we're paying the same fees all the time. And then the block execution time keeps expanding. So here we're just in the limit, right? We're still sticking to 6 seconds the first time, but then we go to 20 seconds. Then this is 6. This is, it just keeps going. And now when we arrive to this, like, block production has completely stalled. Like, the node, from my experience, this never comes back. The runtime can't resist this one. So it just keeps stuck here. It's never going to come back. Maybe if I left my computer running for 3 years, it would eventually finish the block. But so yeah, this is the script basically in action. And coming back to the slides, this is just a table with the same results that we see here.
Can we just look at can we remind ourselves of the code, the code in the palettes for this dispatchable? So I think that's interesting because basically, like, why is the fees not changing? That's, like, I think an important thing to grasp here. Yeah. So we in setting the weight as 1, so it's a constant value. That means that basically, with Frame, like, we can engineer our own custom transaction fee logic, and out of the box, we're using this palette called transaction payment. Transaction fee payment, is that what it's called? I'm bugging on it, but however, there's this logic that handles the way that fees are administered based on a weight. If the weight is constant, the fees are not going to change, right? So this function is basically keeping constant fee, but doing really intense computation linearly, and therefore this is really bad. This is really bad for a lot of reasons. First of all, you want to make sure that there's a kind of a ceiling value, a ceiling sort of amount of computation your extrinsics need to have. And second of all, you need to have correct weights for these complex extrinsics, right? So I'm curious, Bernardo, actually, how would a correct weight look like for this type of violation? Even though it's a violation, like, how would we construct the weight correspondingly?
Yeah, well, so ideally, if you were actually calculating hashes on a loop in your runtime, if that had some real purpose on your on your implementation, the correct path would be to follow these steps, right? And to benchmark it, and then we would have a different expression here on this macro. And this expression would be a little bit more complex. Maybe we would be calling a weights.rs file, and that would be doing a computation that is linear, that grows linear according to n. So n would be a parameter here, and this number would grow basically following this dashed line here, not in the purple line, which is 1 constant.
Cool. Oh, we got some questions. So one question from Bruno is, how would we configure Chaos Scope to work against a different palette? Example, the balances palette.
Ooh, yeah, that's a good question. It's something that I've kept in the back of my head. It's something that we're kind of like open to contributions and new ideas to kind of expand this experimentation to other palettes too. Maybe because right now the palette chaos is kind of self-contained, right? It doesn't interact with any other palettes. It doesn't do anything outside of just assuming that we have a node template with only palette chaos on it. But that's a good question. We're basically open to ideas. If you guys can think of something that, like, hey, maybe if we try to poke palette balances, this way, what will happen? So then it's a matter of writing that code down and just using this sort of automation infrastructure that I put together for Chaos Scope, and just shoot the extrinsics, just shoot the calls against it, and kind of collect back the data and see what happens. It's kind of the idea here, but it's a good question.
Yeah, for sure. There's another question that is asking, is it possible to attack a node by flooding the transaction pool even if the attacker doesn't have enough balance to pay for the transactions? Is the node efficient in rejecting them?
Well, yeah, then it becomes less of an economic attack vector and more of just a technical attack vector, right? Basically, it's going to come down to answering the questions of, does that node have a proper balancing? Is the network properties of that node properly configured so that it has like mechanisms that will eventually reject network interactions that are not really doing anything meaningful? But if the caller doesn't have enough balances to cover for the fees, basically the node is just gonna not execute the extrinsics, and nothing meaningful is gonna happen. So it's just changing the nature of the attack vector.
Yeah. So essentially, like, to add to that, the way that the transaction pool would typically work, sort of, by what I mean by typical is sort of out of the box, no template. And also a lot of like chains are using this, but you know, with Substrate, we can customize these things a lot. But the transaction pool as it is that it kind of does this work. It does a lot of checking for you. I mean, for you as a node operator, and whereby a transaction just simply won't go into the sort of ready to be executed or ready to be included in the next block without passing certain checks. These checks would be, you know, things like, is there enough balance? Is there enough balance? Does the sender have enough balance to pay for this transaction? Is there a tip associated to it? What's the nonce of this transaction? Lots of little checks like this that we can add to the transaction format, basically. And so essentially, it wouldn't go through. So yes, the node is efficient in rejecting them, to answer your question, Angelo.
Yeah. Cool. And I had this funny little slide here just to come back to this point of, like, here we're paying, assuming the caller has enough funds to cover for these fees, they're paying a constant fee to just keep flooding the node with and just increasing the block execution time for a very low fee. And you're kind of trolling everyone else. You're kind of denying service from everyone else. You're just making the chain much slower with pennies. So that's an idea, right? We're illustrating an idea here, a possible economic attack vector. Mm-hmm. So the lessons to take from this is, like, benchmark and design your weights properly. Design your variables properly so that whatever numbers you're keeping track of in your storage, you can trust their representation on storage. You haven't overflowed them. You know they're not representing some meaningless number because you didn't check for the internal logic. And I'm also putting this reference here, Paw Patrol, a tool from Chain Security. Very interesting tool to make kind of security checks on your runtime. And as next steps for this project, things that I have in my head is bringing this sort of experimentations to a relay chain scenario, right? Because right now we're just experimenting on a solo chain. This is just no template by its own, and we're just looking at this problem as if from a perspective that it's a solo chain. There's no relay chain dynamics happening here. So a logical next step would be to use Cumulus instead of node template here, and automate some relay chain deployment on the shell script. I'm working on a lot of stuff constantly on my day-to-day life, so progress is kind of slow here on this project. So if anyone wants to dive into these crazy experimentations, pull requests are always welcome. And again, some references. There's the Alex Popiak's. He has a kind of a similar project on his repo, How Not to Build a Pallet. And he also gave a presentation last year that's sort of going in a similar direction. So yeah, that's all I have today.
Awesome. Thanks so much, Bernardo. That was cool. Can you put those links and those two last links in the chat? That would be super cool so that everyone can see that work and have that reference. So directions for growth. Like you mentioned, like, okay, you're thinking this could be a cool tool to experiment with like a relay chain in a relay chain environment. I'm wondering, like, if there's other like specific extrinsics that maybe you thought about that you haven't just had time to implement yet. Is there like some certain specific like things that you were going to like experiment with to add to the palette itself?
I'm just trying to figure out how to stop sharing my screen.
If you hover over your image, you should see that over your face. Oh, we lost Bernardo. That's okay. We can wait until he comes back. Oh, maybe Bernardo's palette chaos actually broke his computer. Who knows? Oh. But yeah, any questions for Bernardo, feel free to share in the chat. Polkadot.js Plus is available. Yeah, that's cool. Thanks for sharing that. Oh, you're back. Awesome.
So your question was ideas for other extrinsics, right?
Yeah, so like I think this is an exciting project because it's not like it's gonna be sort of honestly, it's partially educational, right? Best practices, and then it has really the potential to grow into like some tool that, as developers, maybe we're writing tests, but then we're sort of using a script in subXT to trash our node, right, and see what comes out of it. So I think there's a lot of things to do. Personally, I haven't put much thought into like what I would do, but I was wondering if you had any like further like directions specifically to like adding to it. I understand that you said it would be cool to have it in the relay chain context, but I'm thinking like adding to like extrinsics. Like, what would you do?
Yeah, well, I have a few ideas in the back of my head. The first one that I started implementing it, but then I just jumped into doing other stuff. The first one would be just, instead of having a unit weight for the the block dragging extrinsic call, it would be to make it as an extrinsic parameter. So when you're calling the extrinsic, you give it not only n, right? Not only the number of times the loop will repeat, but you also give it c, right? Or k for constant. And then the extrinsic weight, instead of being 1, it's c. It's whatever number that call has told it to be. This would give us room to kind of experiment in some other directions, but I really want to explore interactions with other palettes, right? One previous question that was asked in the chat was kind of going in that direction. I think that could perhaps give us the chance to explore things that are maybe more concrete in the sense of substrate developments, maybe things that are more we're actually poking at the palettes that everybody uses and trying to catch any weird behaviors there.
Mm-hmm.
Another idea that's kind of in the back of my head that I showed in the slides for next steps is the automation of relay chain. So, well, there's Polkadot Launch, which is this very popular tool nowadays. Everybody has touched it at some point. But also now there's ZombieNet that Parity is putting forward. And ZombieNet is very interesting. It could perhaps eliminate the need to use subXT. But basically, ZombieNet has its own domain-specific language. So you can write a configuration file that you're telling what kind of transactions you. Well, first you specify a node topology, a network topology. So you put your node Alice, your node Bob, whatever, and they're all talking to a relay chain, and then you automate a bunch of extrinsic calls, and you see what happens. So that could be really interesting to explore how parachain collators would be behaving in this kind of a broader relay chain scenario.
Yeah, but you'd still be writing some sort of script that kind of automates the RPC calls, right? Using subXT, presumably. I mean, subXT seems like a really neat tool to just easily, generate the metadata for your chain, and then be able to send extrinsics to it, right?
I have to get a bit more familiar with ZombieNet. I started experimenting with it last week, and I'm still learning the basics of it. I'm still learning the basics of this DSL, this little dialect language that we have to compose. ZombieNet is meant to be kind of a testing framework for chains. So I'm not yet sure whether it will replace the need for subXT, right? I suspect it will, from my kind of a shallow understanding of ZombieNet that I have right now. But maybe not. Maybe Chaos Scope as a whole won't be needed if eventually we go in the ZombieNet direction. But we'll see.
Yeah, super cool. I had a question, and I actually put it in the question box because I think it just gets it so other people can see. But basically, so if I understand correct, so I just wanted to cover this because if the function, the extrinsic that's producing the hash and in a loop cycle and producing a lot of heavy computation, if it was valid somehow, right, and we were able to fill up the blocks legally, i.e., legitimately, with the available computation space that the block requires, and not more, does that mean that it would be super expensive for anyone to use the blockchain? Like, how can we build this system whereby we're taking into account the fact that if we do allow a transaction that will fill up the block, that anyone else trying to add a transaction to that block will have to either pay a really high fee or just won't be able to add their transaction? Do you think that's something that could happen with substrate-based chains? And how do we mitigate against it?
That's a good question. That's to have an answer with 100% certainty, we would have to dive into code, kind of code that out and see what happens. My gut feeling is that transactions wouldn't necessarily, like the other transactions that are coming from other people that aren't kind of just flooding the chain, right? My gut feeling is that their transactions wouldn't get more expensive. They would cost whatever they would cost anytime. It's just since block production is kind of taken over by this ridiculous extrinsic that we're calling all the time, people won't really have the opportunity to get their transaction into blocks as often as they wanted to. But again, I'm
Mhm.
kind of talking from
Right.
instinct here. We would have to dive into code and really see what
Yeah.
happens there.
Yeah, well, it's been really cool to learn about this, and I think like the takeaway is like, yeah, as developers, like there's best practices. There's certain ways you should do things, certain ways you shouldn't do things. But also on a more meta level, like secure economic designs is a hard problem to solve, and it's an
Yeah.
important problem to think about
And it's
constantly,
not,
right?
and it's not, it shouldn't be a second thought. It shouldn't be something that
Yeah,
when you're developing your chain, you just, I'll do that later. I'll
yeah,
just, I'll think about this later. No, you're writing your extrinsic calls. You should have a very defensive, you should be coming from a defensive standpoint. You should be gaming, war gaming it in a way like, how does this extrinsic call affect my the economic landscape of my chain?
hmm
Can people game this? Can people turn this
hmm
into clever ways to troll my chain or something of that nature?
hmm yeah, definitely. Well, if there's no more questions, I think that we've covered everything, and it's been really great to have you on seminar, Bernardo. And I look forward to seeing how Palette Kscope grows. Again, guys, like watching, maybe you have something to contribute, and feel free to make a PR to Bernardo's project. Um, and with that being said, any last words, Bernardo?
Well, it's been a pleasure.
Cool. And don't forget to send your call for proposals for the Polkadot Decoded 2022. And well, I wish you a very great day, everyone, and we'll catch you in 2 weeks.
Bye.
Cheers. Bye.